Hi, today we will discuss different components of a power grid station. So, what are the main components of a power grid station? Number 1, transformer, which is the most important component of any grid station. Number 2, circuit breaker. Number 3, isolator or disconnect switch. Number 4, current transformer, normally known as CT. Number 5, potential transformer, which is normally called as PT. Number 6, lightning arrestor. Number 7, earth switch. Number 8, bus bar. Number 9, wave trap or line trap. Number 10, protection relays. And at the last, batteries, which are called as heart of a grid station. Now we will explain the function of each of these components in a little detail. We begin with a very important component of any grid station, that is transformer. In the picture we can see an auto transformer with capacity of 250 MVA in a high voltage substation. What is the function of a transformer? It steps up or steps down the voltages, so it can be used for regulation of output voltages. Another important component of a grid station is a circuit breaker. A circuit breaker is a device used to isolate a portion of a grid station for routine maintenance or during faults. Circuit breakers are mainly used for protection of other expensive equipment like transformer, etc. Circuit breaker can be operated either manually, that is during routine maintenance work, or automatically through signal from relay, that is during fault conditions. For example, if we want to carry out maintenance. Similarly, if a fault occurs on the power system, the concerned circuit breaker must be opened automatically to isolate the faulty portion from rest of the system. Circuit breaker is on-load device, that is, it can be operated when the circuit is energized. The circuit breaker is designed with arc quenching medium, which extinguishes the arc when operated on energized circuit. Next component is isolator or disconnect switch. Isolators separate a specific portion of grid station and discharge any residual current left in the circuit to the ground. It provides extra safety during the maintenance work. It is off-load device, that is, it can only be operated when the circuit is open. That is the basic difference between isolator and circuit breaker. There is no quenching medium in an isolator, and hence it cannot extinguish the arc which is produced by operating an energized circuit. Therefore, before opening isolator, first you must open the concerned circuit breaker. Another important component is current transformer, commonly known as CT. A current transformer is an instrument transformer in which the secondary current is substantially proportional to primary current and have same phase as the primary current. A CT operates just like any other transformer. Current transformer steps down rated system current to 1 ampere or 5 ampere. It is mainly used for metering and protection purposes. High currents or voltages of the system cannot be directly fed to relays and meters. Most relays operate on either 1 ampere or 5 ampere current. CT ratios are normally 400 by 1, 800 by 5, 1200 by 5, etc. It means that if there is 400 ampere current on the primary side of CT, the output current on the secondary side of CT will be 1 ampere. Similar to current transformer, we have potential transformer, commonly referred to as PT. Potential transformers are used for stepping down the system voltage to a safe value which can be fed to low ratings meters and relays. The relays are typically designed for voltage of 110 volt and 220 volt. Similar to CT, PT is also used for protection and metering purpose. Next we have lightning arrestor or surge arrestor. It is an important equipment from safety point of view. It is a type of protective device used to save the costly power system equipment from the damaging effects of over voltages due to lightning strokes and surges. Lightning arrestors are installed on all transmission lines entering the grid station. Transformers are protected on both HV and LV sides by lightning arrestors. As transformers are very expensive, so extra safety is provided in terms of lightning or surge arrestors. If there is any surge in voltage on transmission lines, the surge arrestors installed at the entrance of the grid station will ground the surges and prevent any surges to enter the grid. However, if transients or over-voltages occur within the grid station, then the surge arrestor installed on both sides of the transformer will protect the transformer from any over-voltages. The number of surges are recorded on the counter of surge arrestor. Let's see the function of a lightning arrestor. This is a transformer which has an incoming and outgoing lines. Now the transients because of over-voltages can travel towards the transformer from any direction. It can be from the HV side or it can be from the LV side. We have lightning arrestors installed on both HV and LV sides of the transformer. In case of a fault or over-voltages from the HV side, the concerned lightning arrestor will ground the surges and protect the transformer. Similarly, if the surges or transients are induced from LV side of the transformer, the concerned lightning arrestor will ground the surges. This way, the lightning arrestors protect the transformer from any surges. Another safety component of a grid is earth switch. The main function of earth switch is to ground the conductor for extra safety. The earth switch is interlocked with the line isolator, so when the isolator is opened, the earth switch is closed and vice versa. This is done for extra safety to avoid any mishap. Bus bar is another important component of any grid station. Bus bars are conducting bars to which a number of circuits are connected. Electric power from different transmission lines is connected on a single point, that is bus bar, and then further distributed to other parts of grid station as required. Bus bars can be arranged in different ways, that is single bus bar single breaker scheme, double bus bar single breaker scheme, 1.5 breaker scheme, etc. We will explain these schemes in detail in upcoming videos. Next is wave trap or line trap. The purpose of wave trap is to trap the high frequency signals coming from remote substations and diverting them to the telecom panel in the substation control room. These signals can include voice and data signals which are further decoded at the telecom panel. This is relevant to PLC communication. These high frequency signals can cause serious damage to the electrical equipment installed at the grid station because these equipment are designed for 50 Hz or 60 Hz frequencies. A very important component of a grid station from protection point of view is a protection relay. The purpose of the relay is to sense the abnormal condition on a circuit or equipment and initiate appropriate action to isolate the costly equipment from the fault. The relay senses the fault and directs the concerned circuit breaker to open. The relay senses faults through CT and PT, which can be called as the eyes and ears of the relay. Next is the most important component of a grid station from safety point of view, that is batteries. Batteries are the heart of a grid station. Supply of power to protection and control circuits is provided from storage batteries due to reliability point of view. An alternate source of supply is also given through rectifiers. Each battery cell produces around 2.17 volt, which we normally take as approximately 2 volt. For 220 kV system, 2 battery sets of 220 volt each is installed. Total number of battery cells is equal to 110, that is 110 into 2 volt is equal to 220 volt. The relays installed on 220 kV system operates on 220 volt. In the picture, we have two sets of 220 volt each. Each set has a total number of 110 battery cells. This is for the protection of 220 kV system. For 132 kV system, 2 battery sets of 110 volt each is installed. Total number of battery cells is equal to 55. That is 55 multiplied by 2 volt is equal to 110 volt. The relays installed on 132 kV system operates on 110 volt. Now these are two sets of 110 volt each. Each set has a total of 55 battery cells. Thanks for watching. Subscribe our channel for more videos and feel free to ask any question in the comment section.